Hello everyone, I'm Rui Zhao and very happy to be here to introduce our work, zero-shot text-to-parameter translation for game character auto-creation. Our method is the first solution in academia and industry for text-driven game character auto-creation, and our method contains three main stages. The first stage is imitator training, the second stage is translator pre-training, and the third stage is text-to-parameter translation. Game character customization is very attractive and very useful for players to have better experiments in like role-playing games. Here is an example of the game character customization system of the role-playing game Naruto. Here are hundreds of controlling bars for players to adjust so as to customize their own game character. This manual editing process is quite time consuming, so we want to carry out more time saving, more user friendly paradigm to achieve character auto creation. In this paper, we've focused on the text driven paradigm to auto create a game character. Our method aims to optimize a bone-driven game character model, which contains two kinds of parameters. Ones are continuous parameters, as shown here, like the translation, rotation, or scale of the eyeballs. And the others are discrete parameters, like the hairstyle. As the first stage of a method is to train an imitator to imitate the behavior of the game engine. The motivation is that the game character rendering process of the game engine is non-differentiable, which cannot provide gradient information for our method to use. So we pre-train an imitator to imitate the behavior game engine and make the rendering process different. Then we pre-train a translator to take in the clip image embedding of the game character and predict facial parameters. In this way, we train the translator to learn the knowledge between the mapping of the outlook of the game character and the facial parameters. As the prediction stage, namely the text-to-parameter translation stage, our method only takes in the text prompt without any image. So the translator need to have the ability to take in the text embedding to predict facial parameters. Although the clip is pre-trained to align the text and the image in a aligned latent space, but there are still gaps between these two modalities. So we fine-tune the translator on the text embeddings of the input text prompt to predict better continuous parameters. For the discrete parameters, they are very difficult for the imitator to learn because they have a kind of discontinuous representations. So we only train the imitator on continuous parameters, and for the discrete parameters, we propose a kind of text-driven evolution search to optimize the discrete parameters without any gradient information by directly interacting with the game engine. The ablation studies show our method can get improvement by combining the translator fine-tuning and evolution search. Here are some results created by our proposed method, including some fictional characters, characters with animal heads, and celebrities. And so here, these created results are with very high quality. And we compare our method with other SOTA method. Here are the comparison results. We also conduct evaluation in terms of objective evaluation and subjective evaluation. And our method outperform other SOTA method in both these two kind of evaluations. Here is another interesting experiment in which we interpolate the facial parameters between two different characters so as to create characters looks like both the two different characters. We believe this kind of interpretation can bring more fun for the player to play. So in conclusion, we propose a novel text-to-parameter translation method to achieve zero-shot in-game character auto-creation. And to best of our knowledge, we are the first to study text-driven character creation, which is ready for game environments. And the proposed T2P method can optimize both continuous and discrete parameters. Besides, our proposed text-driven game character auto creation paradigm is flexible and friendly for users, and the predict physically meaningful facial parameters enable players or game developers to further fine-tune the game character as they want. So that's all. Thanks for your listening.